Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.1, Problem 5. This is Problem 5 from Section 2.1. Solve the system of linear equations 6x minus 2y equals negative 4 and 3x plus 4y equals 8. So step 1, multiply one or both equations times some value so that one of the variables has the same number in front but with opposite signs. So our options are we can go with a 6x and a negative 6x, or a negative 4y and a positive 4y. We should get the same answer either way. I'll choose the y because they already have opposite signs, but I should get the same answer no matter which variable I choose to cancel. So for step 1, I need to make this negative 2y into a negative 4y. So to do that, I will multiply everything times 2. 2 times 6x is 12x. 2 times negative 2y is negative 4y. And then 2 times negative 4 is negative 8. Don't lose the negative. And the bottom equation can stay the way it is. 3x plus 4y equals 8. So now one of my variables has the same number in front but with opposite signs. I have a negative 4y and a positive 4y. So for step 2, add the equations together to cancel a variable. 12x and 3x is 15x. Negative 4y and positive 4y will cancel. Negative 8 and positive 8 will also cancel. So I have 15x equals 0. So the solution for that is x equals 0. If x is 0, 15 times 0 will make the equation true. 0 equals 0. Or really the right way to work it out is divide both sides by the value in front of the x, which is 15. 0 over 15 is 0. So x is 0. That's step 3, solve for the remaining variable. Step 4, take your answer from step 3 and plug it back into either of the original equations and solve for the other variable. So you should get the same answer either way, but the bottom one seems a little easier to me just because it doesn't have negatives. For that reason, I'm going to work with the bottom equation. So I'm going to start with 3x plus 4y equals 8. My answer for x from step 3 was 0. So 3x becomes 3 times 0 plus 4y equals 8. The 3 times 0 basically just goes away. Becomes 0, leaving me with 4y equals 8. Divide out the 4, and I'm going to have y equals 2. I get 8 divided by 4, which does reduce to 2. So the solution to this system of linear equations is x equals 0 and y equals 2. Or if you want to see that as a point, the x value will be 0, the y value will be 2. So if you draw the graph, these two lines would intersect at the point 0, 2. This point is on both lines at the same time.